Hi, today we would like to see this coding problem of uh, finding the sum of three numbers that should match the target number. So the input will be given as like this. So a list and a target number. So we need to find all the possible ways, possible triplets from this given input list or array, such that the sum should make this target number. Okay. So for this, the answer is this. So the given list is this, and so -8 to 6, -8 to 6 will make -8 plus 8, which gives 0 as a target number. -8 3 5, -8 3 5, -8 plus 8 0, which makes target sum as 0. -6 1 5, -6 1 5, which also makes target sum 0. Okay, so how will we approach this problem? That is, so the basic and naive approach for this is, say, we can iterate in three for loops, and we can check for I is equal to the first one, and we can check the second for loop as the remaining numbers as 3 to 6, and after choosing 3, say for example, we go to 1 to 6, choose any of these numbers and check every combination whether the sum is making 0 or not. uh, so we can do that. And one more thing here in the problem, but this will take n cube time complexity, which is not required because there are other easy ways and optimal ways of doing this problem. And one more thing here is, you need to order in such a way that the smaller number comes in the first, and it is the list will be in the ascending order. So whenever possible, you choose that the the lists, even not only one list, the numbers in your list, the lists should be ordered such that, say for example, -8 is equal. Okay, then it will check for the second number 2 3. Okay, so that is the way the ordering should be. Okay, so can we do in a better way, like not in a n cube time complexity? We can do like, say for example, taking for two loops, like keeping one number and iterating through the other numbers, and using hash table, say for example, in which runs in a big go of one time. For this, what will happen is, there are little bit complexities for this, because when we are trying to build hash table, we need to make sure that the ordering, ascending order, has to be present. So little bit modifications has to be done regarding this coding. This will execute in big O of n square time complexity, and there is an extra space of creating this hash table. So big O of n, it will be big O hash table space. Here is big O of n. So, but more efficient and easy way that we can do for this listing, this kind of choosing the numbers kind of thing, is the pointer method. Say what can we do is, the logic here is, we can do like, so say iterate through the list once. You keep pointers, left and right pointers. If you are iterating through the list and you have kept here, you say our for is I is taking 12 now, and just take left and right indexes, right pointers. So at the next to the this number and the extreme end, and check that. So are the three numbers making a sum of 0? If it is, so just add in the list, in the in the list. If not, move further. So if it is, if say for example, if it makes a sums of 5 which is greater than 0, then what we can do? So what is obvious? It is obvious that our sum, one more thing, before that we need to sort this. So this is the way, this is the logic for this pointer method. First sort and do this approach, because we we want to compare the numbers and do the operations. Say -8 -6 -8 -6, 1 2 3 6 12, 1 2 3 4 5 6 1 2 3 4 5 6 7 8 oh, 1 minus 6 minus 8 minus 6 1 2 3 oh 5. So we can use some possible efficient way in any long ways. This sorting algorithm, it will execute in big O of and log n time. Okay, so then we can check this. So take this number as first for I is equal to -8. That is a current number, and you take, this is a left pointer and extreme end as a right pointer. The number just next to this number is left pointer. Okay, so then add try to add these numbers. So this is 6 minus 2. So minus 2 is less than our target sum. So what does that mean? It means that if you want to move the left and right pointers, which one you want to move? If you move left pointer to the right, what does that mean? As this is in ascending order, this sum will definitely be more. That's what we want. But if you reduce this, if you reduce this, if you move the right pointer to the left, then this sum would actually be reduced, still reduced, but we don't want that. So what does that mean? If the current sum is less than the target sum, you move the left pointer. If the current sum, say for example, if it is +2, is greater than the target sum, then you move the right pointer to the left. That's what the logic here. And until you cross these left and right pointers, say we have moved here as a left pointer. Okay, now this is -8. Previously it was -6. Now it is +1 +12. That -5, right? -5 or +5, +5. So this is +5. So it is more. So what you need to do? You need to reduce the sum by just moving this right pointer 6, which will give here 6 6 7, which will give -1 -1. So this is still lesser. So you increase some more amount by moving the left pointer, which will make 0, the exact sum which we are we are expecting as a target sum. So then save this number, save this in a list. -8 to, this will give our target sum. Okay. So does this iteration stop now? No, it didn't stop. So we want to check further using minus 8. Is there still any other possibility of making 0? That's what we need to check here. So one thing here is, so to checking further possibility, you cannot move one pointer at a time now, because what will happen? We got already the 0 with these numbers, the sum. If you move just one pointer, what will happen? If you move the left pointer, the sum would actually increase, which we don't want. If we just decrease, if we just move the right pointer to the left, the sum would actually decrease. That is also not required. So the only other possibility that we can come up with is move the two pointers. Then it might generate a new combination of numbers which can give the 0. It might, sometimes it may not also, but we want to check that possibility too. So if we check minus 835, it's uh, it is also making 0. So we need to add that too. So as I told in the problem that we need to arrange this in a ascending order, right? So that is what happening with this approach. That is, it is already getting added in the list in the ascending order, like minus 8 2 6 minus 8 3 5. So this is the way we need to proceed. Okay, so how to do further? So still you will increase, you will reduce, you go like move minus this right to this one, this left to this one. So just we are moving both left and right, just what we did previously for this combination. Okay, so whenever we crossed the right and left, we don't want to consider further. That means we already uh, seen all the possibilities that we can make out of the number with the number. Okay, so one thing here is, so it shouldn't even be equal. The right and the same left shouldn't be even the same number, because we want different combinations, right? So we can't take right and left on the same number, same pointer. Okay. So as we talked, we just seen the first iteration of this. So we will go with the next iteration. Minus 6, and start with the left pointer just after the current number. So why haven't I taken from here? Because using this minus 8, we have already seen all the possibilities. We will now iterate just through this left and right pointers. So we need not to consider again from here. Just take uh, the numbers from here, the pointers, left and right pointers. Okay, so we have taken minus 6, 1, and 12. Does that make, what's the sum that it can make? So minus 6, minus 6, 6, 6, 7. It is making 7, which is more than 0. Okay, so we you can reduce the right pointer. Okay, so reduced by right pointer. Now it is giving you a sum of 1. So still it need to be reduced further. So this is right pointer. Now it is becoming 6 plus 6, which is 0, which is the target sum. So we found one more combination with minus 6, minus 6, 1, 5. Okay, so we can still reduce. Um, now we got a combination. We need to move the two pointers at a time. But we need not to actually go further manually looking all this, because we already got the answer here, minus it minus 3, using this. So I'm not gonna check with all the possible combinations. Okay, so this is the logic how we can approach this. So what is the time complexity this will get executed? Time complexity is, it will execute in, say this will execute outer loop in n times. And what is inner loop happening? It is checking, it is moving through the left and right pointers, so it is almost taking n times. So outer loop and inner combinations will make n square time complexity. This efficient approach currently we have discussed. So space complexity is because it is storing like numbers. We are storing this the threatening list, so it is taking a big of and space too. Okay, so we will talk about the actual implementation of this in Python. So definition of three number sum or whatever. Three number sum, which will take two parameters, that is a given list, given array or list, whatever, and target sum. Okay, so what we initially discussed, we will make a new array which we discussed here. So I am creating some what I can keep this. I can keep this as this being triplets. I can put triplets array, triplets empty list, and we need to initially sort this, isn't it? Sort this given array just in Python array dot sort. We need not to give any key or anything here because there is, we are not specifying anything. It will sort array dot sort. So now we have sorted the given list. So what we need to do further, we need to run the for loop, and we need to take the first number and create the pointers for i in range. So this will be length of array. Okay, so we have taken the first number as this one, and we need to mark the pointers. So how we can mark? We can just create the variables. So left pointer is equal to, if we I is equal to 0, just I plus 1, isn't it? Just next to the element which the iteration is happening. And right pointer is equal to, as we know, it will be at the extreme end, which is of index length of array minus 1. So we have created the left and right pointers. So what now? So we have marked these and left and right pointers. We need to check continuously that whether the sum is getting the target sum or not. So we need to make sure, as I told previously, the base condition for running that while loop or something here is the left and right pointer shouldn't even coincide. That means the left pointer shouldn't even be equal to right pointer, and left pointer shouldn't cross, right pointer shouldn't cross the left pointer. So it shouldn't be even this. So the other only thing here is the possible thing, while left is less than right, so left and right, Mm, now we check this and we go further by we have checked that the left is less than right. Now what can we do? We check left and right. Yeah, so we need to make some current number and current sum. So current number is this one. So we need to check. Say the current sum. I will call CS. Current sum is equal to current number. Current number is array of I can just write here. Current number is equal to array of I. Current number plus left. It's not left. Array of current number plus array of left plus array of right. Okay, so we have stored in the current sum. So we need to check this current sum is. We need to check with the target sum. So this will be continuation here. So we got the current sum. If current sum is equal to, first we can check the target sum. That this target sum. What is the thing? We got one triplet already. So just add two triplets. Triplets list we initialized here. Triplets dot append. Triplets dot append. Add a list which contains the current number, array of left, array of right. We append one triplet. And as we talked, there we need to go through the logic again. Like, okay, we got we appended the triplet. So what we need to do further in that iteration itself, we need to check further combination whether there is any one more combination by moving both pointers left and right. How can we do that? So excuse me. So left increase by one, moving to the right side, and right you decrease by one. Excuse me. Okay, so we have checked the is equal to combination. So what if it is like less than? If the current sum is less than the target sum, what we got is less, like -2, and the target sum is 0. So what you can do, you need to increase the number. How can we increase the number? Move the left pointer to the right. So if it is the other possibility is just else greater than 0, but we can write current sum greater than target sum. So reduce the right pointer. Okay, so we will do within this while loop until the left pointer is the right pointer, and we will change the number if the while loop completes. So finally, after running of this for loop and while loop, we will get all the values, all the lists within this big list, return triplets. So finally, we will get this answer. So this will be executing in big O of, this is n, and while loop here it is of, almost it is taking big O of n, so big O of n square time complexity, and space complexity is big O of, it is, we are creating a new triplets list, so make it n, because in worst case we will be storing all the numbers. That is, every number in this list is making a triplet, which is making the given some zero, so we need to store all the numbers. So it is big O of n time space complexity. Yeah, this completes this problem.